Hi, and welcome to another edition of Math with Mr. Douglas. Today, we are looking at solving by addition and subtraction. Are you ready? Here we go. Okay, so pen, apple, pineapple, pen, I'm kind of confused, but hopefully today you will not be confused as I teach you about solving for that magical letter x. And we're going to be doing this by adding and subtracting. And maybe I'll use some pineapples in my examples. We'll see. There's a few things that we need to know. There is the golden rule. Now, the golden rule in life is, of course, treat others how you would want to be treated. And if you get anything from this video, hopefully you get that at the very least. But the golden rule for math is this. What you do to one side of an equation, you must do to the other. You must. Otherwise, the world blows up. Yes, that is correct. The world will blow up if you do not do things to both sides. So why is that? Well, I want you to think of equations like a teeter-totter. Teeter-totter or a seesaw. I like the word teeter-totter. It's kind of fun. So here's our teeter-totter. And let's just say you had some, I don't know, you had some pineapples. That's my pineapple. If you had two pineapples like this, but you had nothing on this side, where would the teeter-totter be? Well, it would be like that, wouldn't it? Right? But if I went and I put two other pineapples over here, the teeter-totter would be completely even. If I went and I took away one from both sides, it would still be even, as long as I'm doing things to the same side. But as soon as I go and I add something different, let's say, I don't know, an apple, it'll become unbalanced if I only do it to one side. So I need to do it to both sides. Now, I've been talking about sides quite a bit. I want you to think of the equal sign as the fulcrum of your teeter-totter. Yes, that's a big science word. Fulcrum. And that is how we split up the sides of an equation. Let's take a look at what that really looks like. So if we had something like this, 5x plus 2 equals, I don't know, let's just say 12. The two sides of the equation are separated by the equal sign. So sometimes kids will want to do a little squiggly line right through this. And this will show you, you have this is your left side, and you have this, and this is your right side. And the basic rule is, if you do anything over here, you have to do the exact same thing over there. So if you can keep that in mind, you will be very successful when it comes to algebra. Let's get rid of that. And let's take a look at some examples. So when you're solving, what you want to be doing is you want to isolate, which means make it by itself, the variable. And usually we're talking about x. So you want to make x become all by itself. So if I had this as an equation, x plus 2 is equal to 8. This means some number plus 2 will give me 8. Well, again, if you have your two sides to your equation, you have to ask yourself, I want to get x all by itself, so what do you need to get rid of? You need to get rid of this positive 2. So another thing I want you to think of is opposites. So what's the opposite of positive 2? Well, the opposite on the number line would be negative 2. So if I'm going to subtract 2 on this side, I'm going to subtract 2 on that side. Because remember, the golden rule said I had to do it to both sides. So if I did that, what are you left with? Well, the x just carries down. What's 2 minus 2? Well, some kids will say, well, that's just 0. It's all gone. And 8 minus 2, well, that's going to be 6. Now, in math, we don't have to write down x plus 0 because, well, we know 0 is nothing. So we would just write down x equals 6 like that. So the idea of opposites and doing the same thing to both sides is really key. Let's take a look at a few more examples. Let's say you had x minus 7 equals negative 18. Okay, again, I want to get x by myself, so I'm going to add 7 to both sides. That's the opposite of negative 7. And I like working always vertically. I like drawing my line here, and I like showing work. Now, if you do this, you are going to get a gold star from your math teacher, because all math teachers love all steps to be shown. So this leaves us with x. And then what's negative 18 plus 7? That's a tricky one. Say it's just negative 11. There you go. Let's see another one. Let's do something that kind of always makes people always go like, what? Negative 6 plus, I don't know, how about A for apple? Equals negative 6. Ooh, that seems like a weird one. Okay, let's see what happens. Well, just because remember, this is why these sides are really important, right? So the A is here, it's positive A, you have negative 6. How do I get rid of this negative 6? I'm going to go and I'm going to add 6. I'm going to add 6 here. So negative 6 plus 6 is nothing, leaves me with A. And then what is negative 6 plus 6? It's 0. So A is equal to 0. Okay, well this is looking pretty good. Now a couple other things that kind of freak out students is when you have things on the other side. So let's say you had negative 12 and you had it equaling p minus 4. Well, again, I want to, and don't worry, remember you have two sides to the equation. So on the right-hand side, I just want to get rid of this negative 4. So I do that by going and adding 4. So I'm going to add 4 right there. And that leaves me with that p there. Negative 12 plus 4, that gives me a negative 8. Now, a lot of kids always like to, they see this, they're like, oh, that's backwards. Negative 8 equals p. I mean, that's fine. Maybe you want to write p equals negative 8. Sure. It's basically the same thing. So that's fine. But realize that this is also okay. Okay? As long as you're showing your work, that is really, really the key. So this has been solving by adding or subtracting. Now, I will show a couple of advanced things because it's always good to kind of preview some of the advanced things. So I'm going to show you something called two-step equations. So you can stop right now, but we're going to move on to like some challenge or exemplary things. And today I just want to just touch upon, just for fun, two-step equations. Because I think some of you, if you're watching this, you might want to go ahead and try some of these. If you haven't checked out my multiplying and dividing video first, you got to do that though. Because this will combine adding, subtracting, multiplying, and dividing. So here we go. Let's go with that. I think it was our first example maybe. So 5x plus 2 is equal to 12. Now a few things here is it's the same idea. So I'm going to, two sides. I'm going to get x by myself. So what do I need to get rid of? I need to get rid of the positive 2. And I also need to get rid of this 5. Because I want to have my x all by itself. So which ones do I need to go and get rid of first? That is the question. So the kind of the rule of thumb is you always want to do your adding and subtracting first. And then you want to do your multiplying or dividing. It's a little bit different than your order of operations. But that's how you want to be kind of tackling things. So for this one, I'm going to go do my adding, subtracting. So I'm going to get rid of this positive 2 by subtracting 2. And that's what I mean by doing your adding and subtracting first. Okay. So I'm left with 5x is equal to 10. So how do I get rid of my 5? Well, what's happening between the 5 and the x? What's happening there? Well, we know that there is a hidden multiplying sign. So remember, think of opposites. What's the opposite of multiplying by 5? Well, it's going to be dividing by 5. So I can do it to both sides because that's the golden rule. And then basically, what's 5 divided by 5? It's just going to be 1. So 1x. So just x. What's 10 divided by 5? Oh, that's 2. So our final answer is x equals 2. So a little preview of two-step equations for everybody. Have a great day. Thanks everybody for tuning into another edition of Math with Mr. Douglas. Hopefully you are on your journey about finding that infamous letter X. Until next time, have a great day.